Hello students, today we will discuss about APT statements. The topic covers in computer integrated manufacturing, 6 semesters as well as 8 semesters. Students, that is lecture second about APT, and as you know APT is automatically programmed tool, and that language based on statements. These statements are like geometry statements, motion statements, post-processor statements, and auxiliary statements. The first of all, geometry statement. That statement also called definition statements that are used to define the geometry elements that comprise the part. And the motion commands or statements are used to specify the tool path. And post-processor statements that control the machine tool operation, for example, to specify speeds and feeds, set tolerances values for circular interpolation, and actuate other capabilities of the machine tool. Auxiliary statements. That statement a group of miscellaneous statements used to name the part program, insert commands in the program, and accomplish similar functions of in auxiliary statements and APT. APT vocabulary words consist of 6 or fewer characters. The characters are almost always letters of the alphabet. In detail of the geometry statement. The points, lines, and surfaces must be defined in the program prior to specifying the motion statements. And the common statements is symbol equals to type of geometry and oblique descriptive data. For example, here P1, P1 is a symbol of geometry which is point, and write point POINT in capital letters, oblique 20, 40, and 60. These are descriptive data, that is coordinate of the particular point. A symbol can be combined of 6 or fewer alphabetical and the numerical characters, at least one of which must be alphabetical. And the table you can see in the slide, that is permissible or not, and why, that is symbols. The maximum characters will be 6 in APT language, and the below 6 letters will be permissible, and above 6 are not permissible in APT language, and vocabulary words only read by APT language. Other words are not permissible. Points. Specifications of a point can be accomplished by the following: designating its x, y, and z coordinates. P1 equals to point oblique 15, 10, and 25. These are coordinated as the intersection of two intersecting lines. That P2 equals to point oblique intersection of comma L1 comma L2. That is basic procedure or a method of writing a particular geometry statement for lines. Lines. A line in APT is considered to be of infinite length in both directions. The specifications of a line can be accomplished by the following: the points through which it passes the line, symbol of line L1 equals to right line line oblique P3 comma P4. P3 comma P4 is denoted of the line segment. Passes through point P5 and parallel to another line L3 that has been previously defined. L2 equals to line oblique P5 comma parallel comma L3. That is writing procedure or writing method of this particular geometry in APT language. Plane. A plane can be defined by the following. Plane have a 3 points through which it passes. Plane notation or a symbol PL1 equals to plane PLANE oblique 3 points here P1 comma P2 comma P3. P1, P2 and P3 must be non-collinear. Passes through point P2 and parallel to another plane L1 PL1 that has been previously defined. PL2 equals to plane oblique P2 comma parallel comma plane 1. That is writing method of this statement in APT language. Circle. Circle is defined by the center and radius. And the circle symbol we can write here C1 equals to circle CIRCLE oblique center 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 comma P1 comma radius comma 25.0, that is radius of the circle. That is writing method of the circle geometry statement in APT. 3 points through which is passage C2 equals to circle oblique P4 comma P5 comma P6. That is writing of the circle geometry in APT. APT rules as per prior discussion, we can say here P1 equals to point oblique and descriptive data here the coordinate of the particular point xyz is interrupted to mean x 20.5 mm, y equals to 40 mm and z equals to 60 mm, that is above mentioned descriptive data. A symbol can be used to define only one geometry element P1 point oblique 20 40 and 60, and again P1 is point 30 15 70. Only one symbol can be used to define any given element, that not repeated. So we can first point assume or mention P1, then next point we will mention in P2, not same in APT language. Motion commands, that is second statement of the APT. Motion commands are the writing of the particular general writing format is here. The motion command oblique descriptive data. Go to like that, go to oblique P1. Go to and commands to the machine tool from one point to next point. Go to oblique P1. From PTRG and that call from the home position of the machine by the from oblique PTRG. Reposition of the tool in APT language. where from is an APT vocabulary word indicating that this is the initial point from which all others will be referenced, and PTR is the symbol assigned to the starting point. Another way to make this statement is the following: from oblique -20 and 0. These are the coordinate of the x, y, z. The from statement occur only at the start of the motion sequence only in APT language. Point to point motions. There are two commands, go to and go delta. Go to use for point to point motion, like that, P1 to move P2, then go to oblique P2, go to oblique, that is a particular coordinate mentioned here, 25, 40 and 0, x, y, z here, and go delta used for preceding the particular operation at a particular coordinate. Go delta oblique 50, 12 and 40. These are XY, XYZ data on the particular preceding operation in APT language. Go delta statement is useful in railing operation. Go to oblique P2, go delta 00 and -50, and Z is -50 here. That meaning of the depth of the drill, and the go delta 00 the 50 again in positive coordinate. That is go delta meaning of the preceding movement of the drill bit or a milling cutter, etc. Contouring motions here we can define in three types: on the drive surface, check surface and the path surface. We can see the diagram in the slide. Here is the drive surface which is supporting the tool or a cutter, and part surface, that is a bottom surface or a, and at the cutting tool surface, and the check surface, that's meaning stop or the end of the motion of the particular tool after then, and the move or a turn of the tool. These are three basic contouring motions here. Like that, drive surface, this is the surface that guides the side of the cutter, and the part surface, this is the surface again pictured as a plane on which the bottom or nose of the tool is guided, and the check surface, this is the surface that stops the forward motion of the tool in the execution of the current command. APT modified words here. To on past. To on past, we can see here in a first to. To meaning touch the object, and that is drive surface, and that is tool path, and that is part surface, and that is cutter trajectory. That's cutter move from here to here and touch to that vertical line or a check surface, that is to. And on meaning and the cross the cutter of the half or equal to radius, then that is meaning the on. And totally cross the particular check surface, that is called past in APT language. Tan to, drive surface is tangent to the check surface. We can see here, for example, here is the cutter trajectory, tool path here, and the plane L1 here, that is drive surface, and that is circle, and that is check surface. The tool cutter move from here to there, and that is touch on the periphery of the circle, that is stopping location of the cutter, that is known as tan 2, because that plane tangent on the circle. that is denoted by 10 to statement. That is particular movement of the tool in all directions. We can see here, or we can see in the slide. Here is the previous position of the tool, and that is center, and the above position of the tool from here to go up, and the go down, and that is go forward, and that is go left, that is go right, and that is go back. The all commands shows our position of the tool according to the particular direction of the tool or a particular movement of the tool. Go left command the tool to make a left turn relative to the last move. Go right command the tool to make a right turn relative to the last move. Go forward commands the tool to move forward relative to the last move. Go back commands the tool to reverse direction relative to the last move. Go up commands the tool to move upward relative to the last move. Go down that commands the tool to move down relative to the last move. These are basic movement of the tools as per last move. From and PTRG here. PTRG meaning starting location of the cutter, that point, and go to plan 1 to plan 2 to plan 3. That is particular wants motion of the tool, that is plan 1, that is plan 2, and plan 3, and plan 4. We can see in this figure. From PTRJ go to L1, go to go oblique 2, comma L1, comma 2, comma plane L2, PL2, comma 2, comma L3, and go right. Here is go right, oblique L3. That plane is L3, comma past, comma L4. Post processor command or a statement in APT here. In this common procedure or a writing procedure here, common the post processor command oblique descriptive data. The post processor statement have all units, tolerances, speeds, feeds, all type of data's vocabulary in APT language. That is called post processor command or auxiliary statements. Here is units, write units, units, units oblique mm. Indicates the specified units used in the program are inches or mm. Intolerance and internal tolerance oblique 0.02 specify in watt tolerances for circular interpolation. Out tolerances the right OUT oblique 0.02, for example, specify the outward tolerances for circular interpolation. Same thing is cutter oblique 20 and defined the cutter diameter for tool path offset calculations, the length and other dimensions of the tool can also be specified if necessary for three-dimensional machining. The mention for the spindle speed, the spindle SPINDL oblique 1000 clockwise direction specifies the spindle rotation speed in revolutions per minute, either clockwise or a counterclockwise can be specified. The spindle on off Then we can write spindle oblique off or on, stop spindle rotation or on of the spindle rotation. Feed rate, FEDRET, feed rate oblique, how many required? Here is example of the 40 inch per minute. Specified feed rate in millimeters per minute or the inches per minute. Minor word IPM or IPR are used to indicate whether the feed rate is units per minute or units per revolution of the cutter, where the units are specified as inches or millimeters in preceding unit statement. Rapid engages, rapid traverse, high feed rate, or next mouse. Coolant on off, that is right, coolant oblique, that is flat type or a mesh type, the right on the oblique statement. Turns cutting fluid on. Load delta, that is use the automatic tool changers to identify which cutting tool should be loaded into the spindle. Delay, we have any delay, then the right format of the delay oblique 30 temporarily stop the machining tool, a period specified in seconds. Some auxiliary statements are used to identify the part program that have part number. It is the first statement in APT program used to identify the program. For example, part number sample part number 1. The machine oblique permits the part programmer to specify the postprocessor, which is a fact specifies the machine tool. Color print, standard for the cutter location print, which is used to print out the cutter location sequence. We have any remark, then use the remark. Write the remark is used to insert explanatory commands in the program that are not in tapered or processed by the APT processor. And the fini at the end of the program. Fini, writing fini, FINI indicates the end of a APT program. Students, these are four statements of the APT language. Thank you.